Hello, good morning. Welcome back to my YouTube channel. Again, this is Mr. Santos Capellan Jr. wishing you always a very nice day. Okay, now what I'm going to do today is try to continue my tutorial for recirculating air handling unit. To wrap it up or to give you an idea, from the previous tutorial, I have shown you how you will be creating uh, BMS graphics for a recirculating air handling unit. I already explained what are the field devices and how it works. Okay. Now, maybe one of your question in your mind is how I was able to come up with these graphics. Okay. Now, if you are following this tutorial or my video tutorial in the first few tutorials, okay, I have explained if you are a BMS engineer, you need to study carefully the project specification, especially the BMS part of the project specification. Now, what are the specifications that you need to look at? First, for the air handling unit, now you have to look for the material submittals or the control schematic diagram drawing provided in the mechanical specification, or you can go and look for the equipment schedule in the mechanical. Then you will be able to see all the type of air handling unit that will be installed in the project. Then in that document, you will see the points being asked from the specification to be included in the building management, control, and monitoring BMS points. Okay, so please review that tutorial. There are several tutorial there for this control schematic. So you will be able to come up with the graphics that I'm having now in my screen. Okay, let me put in full screen. Okay, now so today my plan is to give you an idea to how are you going to do the BMS or the automatic control for this recirculating air handling unit. Okay, so let me go back to my system view. Let me go to the full screen. Now, before you can do the control and monitoring of this equipment, you have to consider, okay, since there are two motors, supply and return fan, okay, so as I said, if there are motors, there should be always motor control. So you will be expecting that there will be one motor control panel for this specific air handling unit. Okay, so your task as a BMS engineer is to specify the control and monitoring points that will be provided in that motor control panel. Okay, so meaning there will be a company control panel fabricator that will provide all the motor control panel for the project. Now, the one in charge in the motor control panel are the electrical engineers. Okay, now you will coordinate with the electrical engineers that you will say, okay, for this recirculating air handling unit, I need these following points. Okay, so what are these points? Now, first, in the motor control panel, you should be able to start and stop the equipment in automatic mode. Okay, so first they have to provide the start stop BMS point from the panel. Okay, now this start stop point will be the basically there will be voltage in that BMS point, maybe 24 volts. It depends on the control transformer or the control voltage of the motor control. Basically, the motor uh, control voltage is around 24 volts. Okay, so it's very seldom you will find 220. Now, as much as possible, if you can talk to the electrical engineer, okay, just provide me 24 volts start-stop BMS points. Okay, so meaning this start-stop of supply and return fan, that contact, actually what your DDC is doing, your digital output coming from your DO IO module will just close the contact so that the 24 volts will go to the or will supply the contactor coil of the supply and return fan. So this control voltage should be only 24 volts. Okay. Now let's say if the control voltage approved by the consultant is 220 or 240, now you need to provide, as a BMS engineer, you will be needing separate relays in your DDC panel to close this 240 control voltage. Okay, because as a BMS engineer, you should be always protecting your DDC or your controller. Okay, so as much as possible, you can accommodate 24 volts in your DO points, but if 240 is the control voltage of the motor control, you have to use separate relays. Okay, now so the first points are the start-stop for supply and return fan. Okay, so that will be 2 points will be provided in the motor control. What else? So you have to ask the monitoring points. So what are the monitoring points? Handoff auto status. So this is the selector switch. Now, as I said, when the selector switch is in automatic, then that's the only time BMS will take the responsibility or the control. So meaning both selector switch for supply and return fan should be in automatic. So they have to give you this BMS monitoring points. Now, what else? Trip status. Okay, so supply and return fan trip status. Okay, so you have 2 for handoff auto, then 2 for trip status. Okay, then 2 for run status, supply and return. Okay, so more or less you have 1, 2, 3, 4, 5, 6, 7, and 8. So you will be needing 8 points, 2 control points, 2 control BMS points, then 6 monitoring points from the motor control panel. Okay, now you have to specifically tell the electrical engineer responsible in the motor control fabrication that in this MCC, for this recirculating air handling unit, I need BMS points. These are the BMS points. For control or the start and stop, I can allow 24 volts. Okay, but for the monitoring points such as handoff auto, run, and trip status, I need volt-free contact. So volt-free contact meaning there should be no any voltage presence in the contact because this contact will just open and close. Okay, so be sure that the points are volt-free contact. Now, the fabricator will give you these points through a relay. Okay, so contact of relay, volt-free contact, it will be given to you. When it is running from the auxiliary contact of the motor control, they will use it and connect a miniature relay so that that relay, if it's activated, the normally open contact will be used for the BMS monitoring points. Okay, I hope you have an idea what I'm talking about. Okay, so if you already specified the BMS points from the motor control, then it's time for you to prepare your DDC. Okay, now in the DDC, as you can see here, I have my automation server. Now this automation server can handle several HVAC equipment. Okay, now in this automation server, okay, I have IO bus. When you say IO bus, this is the connected IO module in that automation server. Okay, now as you can see here, in my previous tutorial, I have added 2 IO module, 1 DO. Okay, so DO, as I said, this will be the one that will handle the start-stop command to the equipment. So from DO, from your DO module, you will be pulling cable going to the motor control panel that will open and close the contact provided by the provided in the motor control in the MCC. Okay, so I have already here DOFC8, meaning this IO module can handle 8 digital outputs. Okay, now initially I have already here 2 digital outputs for my twin exhaust fan. Okay, so I can add the points here. Okay, so since I'll be needing two digital output, one for supply and one for return fan command. So I will come here, right click, then edit in spreadsheet. Okay, so it's easy to add points. So as you can see here, okay, as you can see, I have here 8, then output 1 and output 2 channel are already occupied. So meaning there are already 2 cables from these DO terminals going to the motor control panel of this twin exhaust fan. Now I need to specify another 2 points that will control my recirculating air handling unit. Okay, so I have to specify what is the point because there are several types of point. Now this will be digital output. Then I have to create the proper identifier for that point. So I will say SF, short for supply pan, start stop, CMD. Okay, so I am using a short identifier, but it's descriptive for me. As a BMS engineer, always use a descriptive identifier. SF stands for supply pan, then SS start stop, then CMD command. Okay, because during binding of the points in your graphics, you have to use these points. Okay, so it's better if you will use a descriptive identifier. Okay, now you can always put the specification, I mean the description. So SF supply, or you can make it here supply fan start stop command. Okay, then you will be using the channel output 3. Okay, so here another point, digital output. This time I'm going to use, so I can copy this, Control C. So I will not type Control B. Then I have to change. Now it becomes red because you will not be allowed to use the same identifier. So I will use this as RF. Okay, so return fan. Now here I can copy this. Okay, wait. Let me copy also this, Control C, then my identifier here, Control B. Then I will change this to return fan. Okay. Now I will be using output channel number 4. So this digital output that can accommodate 8 digital outputs are having 4 spare terminals or spare channel. Okay. So we can use this DO for other equipment. Okay. Now, so I am done with the control point, the start and stop. Now I have to add in my system. Let me first save it. Save, yes. Always save the changes you have made. Okay. Now let's go, come back here so we can see. Okay, so okay, it is already there. Then now in my IO module, I have here UI 16. Okay, as you can see here, I have around 1, 2, 3, 4, 5, 6, 7. Okay, now I can use this IO module to monitor also the points from the motor control of my what you call this recirculating AHU. Okay, now I will create here. Okay, so be careful. You have to specify the correct type of the inputs. Okay, now this one will be SF HOA STS. Okay, now SF HOA, hand of auto, SF, hand of auto, STS. Okay. Now, okay, so what else? Another digital input for my, this time it will be RF hand of auto STS. Okay, I will leave the description. I will put it later on so that we will not be spending too much time in the creation of the points. I will just show you the important things that you need to key in. Okay, so what else? So SF run status. Okay, then here another points. So what will be the next point? RF run status. Okay, another digital points. Digital point. Okay, this one is for my SF trip status. Then another digital points here. Okay, then this will be my RF trip status. Okay, so now we still have one spare points here. Okay, so I already created the control point, the start stop. Then I already created the monitoring points, hand of auto, run, and trip status. Okay, so these are the points coming from your motor control panel that you try to specify or talk to the electrical engineer that these points, I need this for my control and monitoring or the automatic operation of this air handling unit. Okay, I guess it's already clear for you. So once you specified it in your DDC IO modules, then the next part will be there is you will ask your technician that they will need to pull cable from this IO modules going to the motor control. Okay, then so the next thing that you need to do is do your control logic programming. So this part is a little bit exciting and a little bit what you call this, you will spend some thinking. Okay, so you need to check what is the sequence of operation for the said equipment before you will do your programming. Now in programming, we are following several steps. First step in program development, you can implement this, know the problem or understand the problem. In this part, understand the sequence of operation. Okay, so the sequence of operation will be provided in the mechanical material schedule or equipment schedule. Then you will check the control schematic. Then in that document, you will be able to see the sequence of operation. Okay. Now, if there is no sequence of operation, if you are a BMS engineer that handles several projects, you can provide a basic sequence of operation. Then it should be approved by the mechanical consultant for the equipment. Okay, so what I will do, I will just give a basic simple sequence of operation. Now okay, let's say you will start the fan if the selector switch of both fans are in automatic. Okay, so that is one of the condition. The next condition, you can start the air handling unit if there is no problem in the motor of the supply and return fan, meaning there is no trip or fault condition in the motors. Okay, so that will be the two conditions. Then what else? Okay, now I have not included here. Okay, I have here fire alarm. Okay, now again, this air handling unit will not run if there is fire alarm. Okay, so that condition is very important because we don't want air handling unit running if there is fire in the area being served. Okay, so we don't want to make the fire more or we don't want to provide more oxygen or air in the area where there is fire. Okay, so that is the purpose why we are always including fire. Okay, so there are three basic scenario or basic condition when you will start this air handling. Okay, so first, as I said, when the equipment is in automatic, that is the only time that the building management system will take the control. Then there should be no trip condition in the motor control panel. Of course, you cannot start something if it is in a trip condition. That is very obvious. Then one important thing is there should be no fire. Okay, so these three things we will consider in our motor or supply pan and return pan stop logic. Okay, I have already shown you this programming in the twin exhaust fan, but I will again do this in my next video tutorial. Now here I've just tried to explain. Once you finish your graphics, then you can create the BMS points in your IO module or in your DDC. Then you can start your control logic programming. That will be done in my next video tutorial because I don't want to give a very long video tutorial. So I want to break it in a smaller or shorter video so that the watching guy will not be bored. Okay, so let me save first. Okay, now I guess this will be enough for this video tutorial. I have given you the idea how are you going to create the points. Okay, so I hope those who are following my tutorial now they have the idea how are you going to do the control logic programming. Okay, you have to prepare something before you write the control logic programming. The one that is very important is to study in detail the mechanical specification for the equipment so that when you start doing the control logic program, you will not forget anything. Okay, so here we are ready to program the start stop of these two fans. Okay, now for the field devices, it will be also specified in the control schematic for this air handling unit. Okay, so whatever is being asked in that document, you have to put it here. Okay, so another video tutorial for this field devices. Okay, so again, I think this will be enough for this tutorial, and I hope I have provided you some information, especially to those new in building management system. Again, Santos Capellan Jr. is saying, if you are have not yet subscribed in my YouTube channel, please support this channel, and you can always click the notification bell. And Santos Capellan Jr. saying, God bless us all, and bye for now.